Hey folks, Doug Blake with Body Design University. Welcome to another weekly study. And in today's video, we're going to go over kind of continuing what we've gone over the past week or two, which is in chapter 12, the different assessments. This one is the pulling assessment. Now I've gone over the pushing assessment. Here is the thing to keep in mind when you get to the pulling assessment. If you look at the solutions chart for overactive, underactive muscles, because that's why we do this, everybody wants to memorize, and it's not that difficult, but it becomes easier when you realize that the solutions chart for the pulling assessment, which is what we're going to talk about today, is, and that's on page 399. Go ahead and swing back. Take a look at page 396, table 12.9 for the pushing assessment. And go see, this is what I do. And guess what? Look what happens. They are exactly the same. Other than that, on page 396, they kind of added in the levator scapula, they put in parentheses the posterior neck muscles. And in the bottom part here, head and neck area, they put in parentheses the anterior neck muscles for the sternocleidomastoid. But they didn't do that over here. That's the only difference. But guess what? Those solution charts are exactly the same. They're exactly the same. So from a memorization perspective, piece of cake for you, right? So now what do you have to remember? Overactive, underactive when it comes to these assessments. You got your overhead squat assessment, your single leg squat assessment, you got your pushing assessment and your pulling assessment. There's not 100 different muscles to memorize, folks. Okay, there's not. And you've already memorized. If you've gone through this chapter, by the way, if you haven't gotten to the chapter, that's okay. You're gonna get to it eventually, and you got to know these overactive, underactive muscles anyway. But one of the nice things about this scenario is that even though they are the same, it gives us an opportunity to kind of go over why those muscles are overactive or underactive, why you see the scenario the way you see it, right? Because there's three basic issues that you're going to see. And again, I spoke about this in the pushing assessment already, but there's three basic issues in the pulling assessment that you're going to see. And it starts from the LPHC, or the lumbopelvic hip complex. And it sort of makes sense, because if you go back to your beginning, or the original part that we spoke about with the postural deviations, this actually makes sense. If you remember what the lower crossed syndrome was, if you go back to the beginning, you can see what is the lower crossed syndrome? What are the overactive, underactive muscles? And there's a chart in there, very basic. Remember to memorize, very basic. Read it, rewrite it over and over and over. In fact, you'll dream about it. You won't be able to forget it if you do it using that methodology. But the point here is that when you get to table 12.11, your solutions chart is pretty straightforward. So let's go ahead and look at it. Now, well, look at it, but kind of put your hand over, because I want to ask you a question. If you can do this, you've got the overactive, underactive stuff pretty much down pat. So here's what I want you to do is take a look at this first. And I am going to pull up the pen, and I've got my overactive. Let me ask you a question. What muscles are overactive with an arched back? See, if you don't even look at the fact that it's an assessment, right? The fact that she's pulling, and she's pulling back this way, they already told you that the back is arched. It's lordosis, right? Well, what particular muscles are shortened? What particular muscles are overactive, are working too much? Because that's what overactive is. The neural drive is high. In other words, those muscles should not be working that hard at rest. Overactive muscles are working too hard at rest. Underactive muscles, they ain't working hard enough at rest. You get the idea? It's all about the neuromuscular control systems in the body. A high neural drive means that those muscles are receiving a high stimulus, actin potential stimulus, that they should not be getting. And that's why they are tightening up or shortening inordinately, inappropriately at rest. Okay, so that's what overactive is. So let's get back to this. If you look at a arched lower back, don't cheat and don't look, okay? What muscles are overactive? Okay, right, the hip flexors, right? Because what does an arched back mean? That's where you can start going back and hopefully, this is what I'm hoping happens. You go through enough of these videos that we've put together here for you, and you start to go, oh, okay, I get it now. It's the aha moment. If you take a look at her pelvis. Now, again, it's a picture of a person. I can't show you the actual skeletal. I mean, I guess I could, but think about it. The pelvis is tilting forward. This is posterior tilting of the pelvis. Now, remember, at the superior aspect, right, of the pelvis, at the top of the pelvis, if it leans forward anterior to the front of the body, that's an anterior pelvic tilt. If the top part of the pelvis moves back posteriorly, like when you do a butt tuck, right, when you lose the arch in your lower back, that's called posterior pelvic tilt. So what we know is that if there is an anterior pelvic tilt, which is what happens when that lower back arches this way, that pelvis is tilting forward. You automatically know it's going to be hip flexors. So rectus femoris, which is one of the quadricep muscles, but works over two joints. It works over the hips and actually assists with the flexion of the hip. The psoas muscle normally is associated with the iliacus muscle, so we call it the iliopsoas complex, or just the iliopsoas. But in this case, they just want you to say psoas muscle, and then the TFL, tensor fascia lata. Just so you know, the psoas muscle is a very, very strong, has a lot of power associated with it. So it is a very strong hip flexor, but it's deep inside. It's hard to palpate the psoas, but what you can do is you can stretch it. And that's kind of the idea when you talk about overactive and underactive muscles, right? Strengthen the underactive, stretch the overactive. So the overactive muscles then are going to be the hip flexors. What else? Now, again, look at both sides laterally. We look at the hip flexors are here, but what's going on over here in the back? What muscles now also assist or aid with increasing the lordotic curve of the lumbar spine? The lumbar what? Extensors, right? Your erector spinae muscles for the most part. So anytime you see this lower crossed syndrome, this arching of the lower back, this increased or hyperlordotic curvature created by the anterior tilt of the pelvis. Again, we're not talking about the normal tightening of the pelvic lower back when you're doing a bench press or what. No, we're talking about an inordinate level of hyperactivity in a position where the body does not need to be in that position. Now, again, this is for your memorization purposes, so you can pass the exam. In the real world, when people are going into this position, it's because they're generally using very heavy weights when they're pushing, or very heavy weights when they're pulling. This is completely different. This is an assessment. Okay, so the pulling assessment, this, by the way, the amount of weight that this individual is using is not a lot of weight. I mean, it's enough to create resistance, but we're not asking during an assessment for an individual to be using, an inordinate amount of weight. Same thing with the pushing assessment. So, but again, that's an aside. So those are your overactive muscles. Write them down. Hip flexors, right? The rectus femoris, the psoas, TFL, tensor fascia lata muscle, which you generally feel kind of on the side, but it has an anterior insertion, that allows it to be a hip flexor. And then the lumbar extensors work alongside, right, to help and assist with that arching, right, that arching of the low back by increasing the anterior tilt of the pelvis. So that leads us then to what? What are the underactive muscles? Well, now think of this. People will get confused because they'll see the word extensor here, but that's lumbar extensors. That's not your pelvis. Okay, that's not your hip extensors. The lumbar extensors are not your hip extensors. Now think about this for a second. If the overactive muscles are flexors at the hip, okay? The overactive muscles are flexors at the hip. What muscles have to be allowing for those hip flexors to be overactive? This is the kind of the thinking you got to go through. Well, it's got to be the opposing or the antagonistic muscles to hip flexion, which is going to be what? Hip extension, right? What are the two hip extensors? The main hip extensors, the gluteus maximus and the hamstrings. Those are going to be your main hip extensors. And that's why the gluteus maximus, students say it all the time. They're like, when they have taken the exam or when you really start to understand fully what we're talking about, the glutes are like always the underactive. Glutes are seldom, and I guess I'd have to check, but I don't think I've ever seen a scenario where the gluteus maximus is like overactive. I mean, I'm sure it could be, but not in these normal, scenarios that we're talking about. So your overactives are your hip flexors, your underactives are your hip extensors. Now, again, you're memorizing gluteus maximus. By the way, they don't have it in here, but generally the understanding, and probably they don't even think they'd have it on the exam questions, but just so you know, the gluteus medius works in conjunction with the gluteus maximus in certain positions of the femur and the hip. Thankfully, they made it easy for you by just saying there's two underactive muscles you need to know for this particular assessment, and the same with the pushing assessment. So there is your first issue that you're generally going to see when people do this, right? You're going to see them arching the back, right? And they got their rib cage up. There's nothing wrong with that from a training perspective. This is during an assessment. Okay, I want you to keep that in mind. What's the next one that you're going to see? Well, for sure, you're going to see the classic elevation of the shoulder girdle or scapula elevation, right? Simply lifting, you're shrugging. And it's pretty obvious that in this case, this individual has really elevated the shoulder. You may see it to that extent. They're doing it obviously for the sake of showing you what that movement looks like. That's no bueno. That's no good. We don't want the shoulder girdle elevating when we're doing rowing movements. Anyway, by the way, just take a step back for a second. Stop. Don't look at this in the real world. How would you fix this anyway? Now, during the pulling assessment, you can obviously say these muscles are overactive, these are underactive. One of the reasons why I generally never have to do this is because look where she's pulling. Look where she's pulling the cable. Now, when you do a row, just think about this in the real world. When you do a cable or a pulley row, where do you generally pull the handle? Exactly. We're going to tell that person to pull it down here. That's actually going to drop the shoulder girdle when we do this in the real world. But there are some other issues that, of course, we talk about in the Body Design University course. We go over other real world scenarios that you're going to see with this. But the point is that when they pull way up here to the top of their chest, well, of course, they're going to shrug their shoulders. But again, the point is that from an overactive for NASM and memorizing their material, what are the muscles that elevate the shoulder girdle? What are the muscles? What's the primary muscle that elevates the shoulder girdle? When you're doing shrugs, you personally, right? You're doing shrugs. What muscle are you trying to build? Your traps, right? Well, it just so happens that there's three main areas to your trapezius muscle, right? It's the upper trap, middle traps, and then lower traps. And ironically enough, the same muscle can essentially, quote, fight against itself. It's interesting in that the upper fibers of the trapezius can be working quite actively, and then you can have sort of a normal neural drive to the middle and lower. But if the neural drive is really low to the lower part of the trap, but really high to the upper part of the trap, this is what we see during the assessment. So the overactive muscles are what? There's basically two of them. And it's interesting that NASM decides to throw in the levator scapula, because I don't often see that. And from a kinesiological perspective, it's a very, very important muscle when it comes to these overactive, underactive scenarios. The levator scapula can be a huge problem for people, especially when you're sitting at a table all the time and you're constantly in this shrug position. This guy right here is actually a very important muscle when it comes to disruption or corrective exercise. The other muscle, of course, is going to be the upper trapezius, like we said, right? When you're doing shrugs, you're trying to build your traps, right? We're trying to build our traps and get that, muscular hypertrophy up there. Well, those are your two overactive muscles. If you see somebody shrugging during pushing movements, pulling movements, things like this, those are your two guys that NASM wants you to remember. But keep in mind, if elevation, right, elevation of the scapula is overactive, then what's going to be the underactive? And there's only one that they want you to know, and that is the lower part of the trapezius. Okay. Yeah, I know the serratus anterior and the teres minor are involved with, movement downward, depression and protraction of the scapula, but gravity is already helping you with that anyway. So those muscles are not, quote, underactive. They're not part of this scenario that we're interested in talking about. They want you to basically memorize that the lower trapezius is under, it is allowing the upper part of the same muscle to work too much under this scenario. And so the lower trapezius becomes effectively underactive. It should be doing more. If the lower trapezius would simply do its job in this scenario, you wouldn't be doing this, basically, is what this is saying. Think about the same thing over here. This is kind of the way I always think about it. If your glutes would just do what they're supposed to do, they wouldn't allow this to happen. You get the idea? That's kind of the way I think about it. And this is so this is generally the second issue that you'll see. And then, of course, the third issue is what we've seen this before, this forward, what we call jutting forward. And let me try to do it from the side for you, right? Jutting forward of the chin with a stable torso. It's the key. That torso is stable and the chin juts forward. That's generally going to be due to a couple of issues, right? Because of the overactive nature of a couple of muscles and underactive muscles, allowing for this positional change to take place. Now, again, if you look back at your postural distortion issues, you would already kind of know what muscles we're dealing with. What are the overactive ones? Okay, what are the overactive? Think about it. The levator scapula, again, because you'll notice that there is elevation of the shoulder girdle. Take a look at this versus this. Okay, you'll notice that that's fine. The shoulder girdle is collapsed down, but you'll notice that in these two scenarios, you've got an elevation of the scapula, right? So the levator scapula is essentially, for the most part, sort of a primary elevator of the scapula, meaning shrugging up. Now, interestingly enough, you won't see the sternocleidomastoid spoken about in the middle issue that we're dealing with. Why? Because the sternocleidomastoid, by the way, you can palpate. That's the guy that jumps out when you turn your head. So the sternocleidomastoid, you got one on each side, and they kind of cross down and meet in the clavicular insertion right here. Okay. And so they turn the head one way and they turn the head to the other, but collectively, the two of those will actually pull the head forward. Okay. They will pull the head forward. Again, think about the two different movements of the head. There's movement forward and there's movement downward. So if you use your chin as a reference, there's two basic movement patterns that occur in the cervical spinal area. Okay, the first one is the chin. Now I'm just sitting up straight. Think of it. You put your finger on your chin, keep your chin up here. If I move my chin forward, okay, in the sagittal plane, I move it forward like this. Okay, that is caused by the sternocleidomastoid. It's one of the muscles that do that. So it pulls the chin forward this way. But what is the other movement that can happen in the sagittal plane in the cervical vertebrae? Flexion and extension. Flexion, extension, right? So the chin can move downward and back up. So you see the two movement patterns that can occur. And that's what we're dealing with here, is that the overactive muscles are lifting the shoulder girdle, and then the other muscle is pulling the head forward. So the levator scapula is lifting and the sternocleidomastoid is pulling forward this way, not flexing the cervical vertebrae. That's not what the sternocleidomastoid in this case is doing. I hope that makes sense. This leaves the most confusing. This is what confuses students the most, and I understand why. I've done a video where I basically had a drawing of that big old head, and I made it so you can actually see the cervical vertebrae. Now, when I say that the deep cervical flexors, right, well, NASM says it, are underactive, this gets a little confusing because folks say, now, wait a minute, my head is moving forward. Wouldn't they be pulling forward? The answer is no. Because the chin is jutting forward, when the chin moves forward, the skull has to actually lift up to compensate. Does that make sense? The skull lifts up. You have to actually extend the cervical spine to keep your eyes kind of going forward. Otherwise, the sternocleidomastoid would pull you down like this. So to compensate, the cervical flexors have to release and lengthen to allow for this compensation of cervical extension. That's why we see these upper crossed syndrome. That's where the upper cross syndrome comes in. So that's why the deep cervical flexors are underactive. Look, again, NASM made it easy for you. Technically, when you see this jutting forward of the chin, that means the cervical extensors are working. But I don't want to confuse you. Simply use what they have written down here. They've made it easy for you from that perspective. So your underactive muscles are your deep cervical flexors. Your overactive muscles are going to be the sternocleidomastoid that's jutting the chin forward. Again, if you kind of do it yourself, take a minute and just do the movement patterns yourself. Flexion and extension are cervical flexors and cervical extensors. If the cervical flexors are overactive, if they're working too hard, you pull down this way. Well, that's not what we're seeing in this particular disruptive position during the assessment. We're not seeing flexion of the cervical spine. We're actually seeing, again, if you look at the picture, we're actually seeing extension. That's what allows the jutting forward to stay with your eye level being maintained during the movement pattern. Look, if you have any questions, I guess I can go on and keep talking about it. But the fact of the matter is if you don't understand it, of course, let me know and put a comment down below. Again, I've done some other videos that speak directly to that particular issue. It's really quite interesting because, again, it's a fairly complicated part of the body, the cervical vertebrae. And because, again, people sit down all the time, we're doing this all the time. You can see me. I'm sitting here, I'm looking at a book, I'm at a computer, I'm doing all of this. And these are the real life scenarios that we see with folks. And what ends up happening is over time, it's so subtle. It is so subtle. What happens is that you get this just minor decrease in neural drive to the cervical flexors, this slight increase in neural drive to the sternocleidomastoid and the levator, and slowly but surely, people go from this. See, I can do my stuff this way to watch, to you don't even notice this subtle little difference of me moving forward, protraction of the scapula, internal rotation of all of those things that we talk about. NASM talks about in these chapters, but staying on target, staying on target. The pulling assessment from a purely memorization standpoint, it's the same as the pushing assessment in this particular chapter. So look, it's always a pleasure for me to go through this material with you. Of course, if you like our content and our material, please subscribe to our YouTube channel, and then you can always look for notifications, right? You hit that button, you'll be good to go, right? So let us know if you have any questions specific to this particular video down below. If it helps you, let us know that as well. If you have more questions related to this or something that even is closely related to it, for sure, let us know. Our goal at Body Design University is to help you pass the NASM exam on the first go around, unless, of course, you've taken it and failed. Well, now it's your second time. And I hope if you've taken it more than twice, we're here to assist you to pass it at whatever point you're at. Please let us know how we can be of assistance to you. Again, it's always a pleasure. Have a great weekend. We will see you next week. Thanks.